with them, 14 languages. Voice is the most natural user interface to devices around you. So the idea is not to actually keep typing and texting, but it's about the usage of voice, but in native languages, which actually work very nicely. And that means that you have to make sure that the use cases are built on top of it. So that's what our focus is from a processor standpoint. One final note, and given that I have maybe just 1 minute, another aspect of heterogeneous compute is disaggregation of compute within the network itself. What I mean by that is, at some point in time, you might have extremely good connectivity to the network. And at some other point in time, you might have zero connectivity to the network. And the question to ask is, do you want your AI user experience to be invariant to the quality of the communications that you have at that point in time, or do you want it to depend on it? Obviously, you want it to be invariant. That means you must have the ability to run inference directly on devices. Not that you want to do it all the time, but when you can, why not? Today, we can run up to a 10 billion parameter model, multimodal model, state of the art on a smartphone, and a sub 1 billion parameter model in your glasses without necessarily charging your device the whole day. It's once every 24 hours. So we've come a long way in that, which means use the data centers, use the edge cloud as and when necessary. They have a role to play. At the same time, make sure that we also build for devices where the inference actually occurs and users directly perceive. That's where the data originates. So it's important to think about it that way.
I think there's also yeah. There's also a very strong environmental aspect to this, and which often gets unnoticed and undiscussed. But that element is also very important in terms of efficiently managing the energy requirements, because energy, as we also know, is finite. And so I think one thing which has struck to me, which you spoke about, was inferences. And a lot of what's happening in India is also around inferencing models, right? So, I mean, in terms of the Gen AI story, which we have almost 300 Gen AI startups, which are building on top of the large language models. And India is definitely leading the way in terms of application layer. There's no doubt about that. Now, of course, with Sarvam and others, we are also building sovereign large language models, right? So we are sort of, as Minister Vaishnav has spoken about, every piece of the puzzles, we are there in terms of fitting that puzzle together. I'd like to come to Mr. Arun Shetty. Sir is with Cisco, and we just want to take it further from where Durga sir had left in terms of talking about enterprise adoption at scale. And of course, with Cisco, what are the challenges or bottlenecks which you see in terms of compute availability, connectivity, which Cisco is trying to do, which you see generally in the compute architecture, also in terms of AI access and also integration complexity? So we'd love to get your thoughts in terms of those bottlenecks, and yeah, we take it from there. It's like the mic is not. That's the first bottleneck.
Yeah. So as you know, we connect and protect the. This one works. Yeah. This should be working, right? Yeah. As you know, we connect and protect even in the AI era, right? Yeah. We started in the internet, we came into the cloud, and we are in this era. First of all, thank you very much for having me, and it's indeed a pleasure to be representing this esteemed panel. So I think what I'll do is I'll summarize based on what others have spoken, actually, and I think those are real problems. The first one is clearly the three impediments for AI adoption is, one is clearly infrastructure constraints, and we all spoke about it, and they all spoke about it. The first one is the power. Power is a challenge, will be a challenge. I think US is expecting it will be 63 gigawatts of power in couple of years, what they require. Okay, and then the compute is a problem. We did recognize that the compute is becoming a problem. And then Kamakoti sir did tell that Cisco is in networking. What are you doing in networking? And networking will be a problem, actually. And then we need to see how we need to address. And clearly it has to be a fit for purpose solutions, because you not only do huge data centers, and I think what we see is in couple of years, you will see there is more inferencing happening at the edge. And that's what we need. That's how the world will move. And that's why solutions have to be fit for purpose, for sure. The second bigger challenge what we have is the security and the safety aspect. So that is something what we need to pay a lot of attention, because as the adage says, what if you can't see, you can't trust. right? You can't trust something what you can't see. So you need to have the visibility across the stack, and also you need to see whether the models what we are using are the right models for us, or is there anything malicious into the models itself, actually vulnerabilities in that model. So the security aspect becomes security and safety aspect becomes very, very important, because the models hallucinate. You can inject toxicity into the model. So those are the challenges what we need to address as far as what we use. So I think it is very, very important to build our models. And if you look at the models, all the models were built using the public data, which was the text, voice, and video data. So, but however, the enterprises, the government has the best data sets. So why can't we use those data sets? So the third impediment what we have today is the data gap. And data gap is essentially, I need to have high quality, accessible, and manageable data. And we can build GPTs using that. What we can call it as a machine GPT, what we can build using that, use that for inferencing, use that for training, use that for inferencing, and we get a lot of quality use of AI. Without data, which is the fuel for the AI today, you can't really move forward on the AI. And I think these are the typical three problems. And the ways we are looking at addressing this is clearly, one is, I will not be able to build a huge data center for a specific use case. So take a use case and then see how fast I can give that infrastructure, a comprehensive secure AI factory or a secure infrastructure, whether it is in the data center or in the edge, actually, so that people can focus on building the use cases or the applications on top of it. And the second thing comes on the safety and the security aspect of it, and how we can do the defense mechanism. And the third one is the data. So these are the three problems what Cisco is trying to address, along with the ecosystem partners, of course, because this is not a problem what you can solve alone, actually. Yeah. Thank you.
Yeah, I think I don't know if my mic. Okay, it's okay. Yeah, and I'll sort of take from the security point which you have spoken, and I'll come back to Dr. Kamakoti. I think we have on the clock it shows 7, but on my watch it shows 15. Yeah, so I'll go by my watch. Yeah. So Dr. Kamakoti would like to focus on critical infra and public systems here, and as you know that, as with the advent of AI, we are going to use it across these sectors as well. So how important do you see heterogeneous compute in terms of contributing to national resilience, to safeguard and to sort of, ensure that our critical infrastructure, public systems are secure as well?
So today, the type of things that we need to do for each one of these actions, right? The type of inferencing, type of response time we need, as Shetty mentioned, it's going to be different. I hope all of you have seen yes, Prime Minister, and always they say need to know, right? You need to know, right? And now what happens is, if I am going to make a model that has understood the entire data, then the model, and it is used by someone, that someone should need to know that data. That's a very important question. So that's where the entire aspect of cybersecurity comes in, and that's why we are all saying that we need to have sovereign models. As he rightly pointed out, we can have adversarial AI, we can go poison the whole thing and then make it tell things that should not be told or need not be told. Okay, so this is something that we need to very much look at from a security point, where I do an inferencing and my training data set goes for a toss. Number one. So we need to have something for education, at least as a director of one of the premier institutes in the country. What my worry is that for education, like how we have censor board for movies, what we should make models for which certain details alone should be fed into it. See, AI is a bacha, right? Whatever you teach, what it will tell you back. Probably do a little more generative on that. So this is number one. Number two is, again, coming back to Cisco itself, right? You do deep packet inspection, and basically you do it based on signatures. Today, the whole story is changing. Dynamically, the malware can change its signature. So that's going to be the biggest challenge now. And what sort of inferencing they are going to do? They have to bring some more different architecture, and that will be an heterogeneous architecture. Now, and so ultimately, as he see, what you see, the trust component. I always repeat this. I'll finish with this with my 1 minute. So trust is, friends, if you want to define A is equivalent to B, that's the definition, right? If you want to define A, you have to come with B, which is equivalent to A. So equivalence in discrete mathematics, equivalence relation should satisfy three properties: reflexive, symmetric, transitive. Trust is not reflexive. I don't trust myself sometimes. Trust is not symmetric. I trust Sarah. Sarah may not trust me. Trust is not transitive. I trust Gokul. Gokul trust you. I may not trust you. Trust is in addition. Trust is context dependent. I trust you on something. I don't trust you on something else. It is temporal. Morning I trust you. Evening I don't trust you. So, right. So the main thing is we have to build that mathematically defined trust. And if you go to some of the search engine and define trust, you get 1 million hits for that. So that is going to be the most important part. So specifically on the heterogeneous, we will have certain different types of security issues, something which AI can solve, something which is originating because of AI. And that's where all of us, edge, connectivity, server, all the three people have to work together. And we will teach and he will put policy. So on the,
So, but both of you are equally playing an important role in terms of policy. Dr. Kamoti, you're also, very influential and important figure in India's AI policy. So, of course, lots to learn from you. Gokul, very quickly would like to come to you and, just sort of taking away in terms of the practical deployment models and what are the sort of examples you're seeing which demonstrate that we are moving towards heterogeneous compute, right? And what needs to be done to also get to that level?
I'll started off with workload and I'll go back to the same thing. So one of the things that we're looking at and it's critical is to see what vertical really needs what kind of domain specific models, and then try to apply that as much as possible as edge inferencing and contain the walls that are there that prevents AI to work efficiently. Primarily, it's like memory, the connectivity, the I/O, the thermal, and then the power. So from an edge inferencing standpoint, there are quite a few things that are being done, be it an education segment where you want more translation, data being available, transcription, so that the knowledge is being imparted in a way that you have with the right data with the lowest power that's meaningful for the student. And more importantly, when we talk security, it's not only about protecting data, the models, we keep talking data and models, it's protecting the user. That's even more fundamental, and how you can ensure that that happens. Second thing is applying it to other verticals, be it small and medium business. I think there is a great opportunity there where edge inferencing and putting compute with the right kind of power that can translate the businesses into actually using AI more effectively. The last aspect that I want to also touch upon is in terms of just power. As we go from 1 gig to 9 to 10 gig in the next 5 years in the country, we have to realize that India is challenged by three physical things that we cannot run away from: land, water, and power. And these are very important aspects that it will drive how we set up our infrastructure. And almost 100% of your power energy that comes into a data center, 40% goes into cooling, 40% into your compute, and 20% on connectivity. And there is this famous metric that you use, the PUE, the power usage efficiency. It has to be as close to 1 as possible, where all the power that you give goes to the most important thing, which is the compute, not to the cooling and things. And there is a lot of technologies that are being played with respect to how much you can air cool on a rack per rack, and that was okay up to about 25 kilowatt. And as you start to get to hundreds, you have to use liquid cooling, and then how we can set that infrastructure up. And for a country like India, it's absolutely important to look at what hybrid energy solutions we can go with, because just pure renewable may not be able to address it. You will have to have something that is stable and be able to do something off grid, so that there is that dependency for you to get the data from the data centers and push as much as possible to edge, because edge is all about reach. How can I take it to places across the country where there is no access to connectivity? It's about how can I leapfrog with verticals that have not used technology as much, We've always done a leapfrogging in India, and this is a great moment for us. And total cost of ownership. Those are the big areas.
Thank you, Gokul. And I think as we are approaching the end of the panel, I'll sort of like to go to Durga and Dr. Shetty also in terms of closing remarks and the way forward. So to both of you, I'll pose this question in terms of the next 2 to 4 years, because I think in the AI age, we don't think too far ahead. We can't do 5-year planning or 10-year planning. I think 2-year planning is sufficient. So what enterprise outcomes are you both looking at? Maybe we can start with Durga in terms of defining India's access to compute, access to infrastructure, capacity, and also sort of building in scale, cost efficiency, and energy efficiency. So, yeah.
So I'll keep it brief. I think what I'm looking forward to with all the conversations here and in other parts of the world as well, where the problems are somewhat similar, is the ability to distribute compute across the entire network. So think of a combination of inference that runs in devices to the largest extent that's possible, edge cloud, on-prem servers where a lot of the localized processing can be done. And these can be done in air-cooled cards, by the way. The point that was made earlier is absolutely relevant. You don't necessarily need liquid cooling all the time. You can do air-cooled cards and then just use air-cooled servers and running up to 100 to 300 billion parameter models, which are getting pretty sophisticated. That's the edge cloud. And as you go deeper from there onwards, then you have the data centers. It then mitigates the overall requirements on what you need in a data center. And instead of therefore concentrating the entire compute in one single location and then building it for just that alone, a holistic approach of devices, edge cloud plus data center is probably what we are looking forward to. From Qualcomm, we call it as hybrid AI. It's not just a marketing slogan, but it is something that we truly believe in.
Thank you.
Yeah. Since the infrastructure part has been addressed here, so let me talk a little bit more on safety and security aspects. So I think one of the things what we need to understand about the models is these models are very intricate and very complex. And it's also non-deterministic, because if you give an input, not necessarily the output will be the same like a standard application, correct? So that's why it is non-deterministic. So what one should be doing, right? There are two aspects of safety and security. I'll just touch upon why it is important to know that actually. Safety is all about, we want the models to work in a certain way, but it is not working in that certain way or the way we want them to work actually. That is the first part of it. That's where the toxicity part, hallucination, all those challenges come actually. The second part of it is the security part, wherein a bad actor from outside can change the behavior of the model. So we need to be careful about both the things actually. So what one should be doing? Say for example, I think Kamakoti sir also told about users to have that security. So users also to be secure, right? So it is essential that the organizations or the country has to build that actually. So which means if I am accessing a chat GPT and sending some confidential info, the system should stop me. So that is when I'm accessing a third party application, the system should be smart enough to stop me saying that, hey, you can't be sharing that information. That's not allowed for you to share that. So that's something which is already happening in organizations today. The second part of it is the first party application. I'm building an application and I'm using a model. So now the organization should be able to scan what all my AI assets are, because one of the biggest challenges for enterprise is the shadow AI applications. They don't know what people are doing actually. So I need to clearly know what all my assets are. That is number one. I detect all my assets or discover all my assets. And next is I should scan and also ensure that these models and the applications what I am using are not vulnerable. If it is vulnerable, then I need to put guardrails around it, or I need to fix those problems. And similarly, there are organizations who are already telling that there are a lot of risks. So you need to NIST, MITRE, and OVASP are telling that there are a lot of risks associated with that, and we need to ensure that we need to stop that. So that is something what Cisco is our focus to see how we can use AI to defend against all these maliciousness and also the vulnerabilities what we see.
Yeah. Thank you so much, Dr. Shetty. I think with this, we'll probably close the panel, but I'd like to invite Honorable Minister Sir once again for his very quick closing remarks. Sir, you've sort of set the stage so well, and I think all of us were highly motivated to sort of build on this. You've heard us in the last 1 hour. What are your thoughts? Would love to hear from you in terms of your closing address.
Thank you, Rizvi. And in fact, it's a great pleasure to be with the eminent Padma Shri Awardee, Professor Kamakoti ji and Gokul ji and Durga Prasad ji and Mr. Shetty, sharing their truly professional experience and how, as a policymaker, how we should view the things, especially in terms of power, electricity, water, and the land. How we should be well equipped to provide all these things, where all the eminent panelists over here or the eminent people of the days would be thinking of putting. My primary challenge they have posed before us, try to provide all these things. We are here to provide the rest remaining. And in fact, thanks once again for a very apt dialogue over here. Ultimately, we have to all, me as a policymaker and you all technocrats and innovators, have to think the basic agenda for this AI Impact Summit: welfare for all, happiness for all. Thank you for inviting me.
Thank you so much. With this, we will have to close the panel. I'd like to thank all our panelists and also invite our colleagues, Sarah from Intel, to hand over the gifts. Yeah, but we'll just have a group photo.